Good day, everyone. Welcome back to my Inferential Statistics course. I am your instructor, Sir Ivan Brian L. Indactivo. So, for today's lecture, we will be discussing our lesson one, basic definitions and key concepts in statistics. So, shall we? To start, we need to understand the learning objectives of this course. The course intends to allow us get familiar or acquainted with the basic definition, key concepts, terminologies, jargons in statistics. These terms will allow us to also understand how it will also come into play in the entire application or implementation of statistics. So, to start in defining terms, let's begin with the term statistics. Again, statistics is the science of collecting, organizing, analyzing, and even drawing conclusions from a set of data or a set of target information that we had. So, as a discipline, it concerns itself from collection, analysis, and later on inference building or the probabilistic approaches that we try to arrive at or the conclusion we wanted to extract from data sets that we had. Okay? Which means when we try to look at the perspective or the spectrum of statistics, we have this part or the initial part that talks about describing the reality, the phenomenon, or simply stating the facts. That is the part where we call descriptive statistics. It only presents how the data is out there and allows us to analyze it as it is. Now, when we try to compare, to correlate, or to make sense out of this and draw a conclusion from it, we try to come up with new ideas or insights. That is when we venture on the second part of the statistics field, which is inferential statistics. Descriptive statistics is usually known as the basic or elementary statistics, while inferential statistics covers what we call the advanced statistics. So these two uh, fields of statistics are very much related to each other. That it is vital for inferential statistics to gather its data arriving from descriptive statistics. And inferential, as the word implies, it tries to infer or draw probabilities or conclusions coming from descriptive data. Now, what are the key terms and definition that you need to understand in commencing the statistics course? The first keywords that you will encounter that is also prevalent in the entire course will be the term population and sample. So you'll see here at the diagram, you'll see the image here that the population represents the entire volume of data set or interested elements that we wanted to study or analyze. And out from that population, we will be doing some procedures or what we call the sampling technique or the sampling process. And we will extract what we call the sample or simply a portion or a parcel or a representation coming from the population. And when we try to look into the sample, analyze it, and draw conclusions from it or its nature, its attributes, then we try to attribute it to the entire population. That is when we call it as part of the inference or inferencing. So, by definition, how do you distinguish population from sample? Population refers to the complete set, all the elements. For example, all the entire population of the students or all the faculty members in a school or in a university, all the, let's say, the citizens of a community. So we pertain to this as the population. Example here will be all high school students. While on sample, it's a subset or a portion or a parcel of data coming from the population. So it might not entail the entire population, but it is extracted from the population. So it could be possibly um, a percentile of the population, a representation of the population, or selected participants or elements in a population. So it's a subset. Example here will be 50% of all the high school students given at every grade level. Okay. So you see the distinction between population and sample. Now, when we try to look at the attributes or how we try to describe the data out of this population and sample, we deal with what we call measurement. So, as the word implies, it tries to provide us the number or the attribute or the characteristic computed coming from the population and from the sample. So, when we talk about measurement coming from the population, you're referring to the parameter. When you're talking about the measurement coming arising from the sample, then you're referring to the statistic. Okay. So how do you define these two terms? When you say parameter, look at the word parameter. Um, it talks about the entire population, the attributes, the measurement that describes or pertains to the entire population. So when we try to compute for the frequency of the population, that's a parameter. When we talk about the mean of the population, that's a parameter, or the proportion, or the percentage, that's a parameter, or the standard deviation of the entire population, that's a parameter. On the other hand, when we talk about statistic, we're talking about the characteristic of the sample. So we're only limited to the traits and attributes of the sample. For example, the mean of the samples, the proportion, the percentage of the sample. So it might be true to the sample, but not necessarily reflective or representative to the parameter. But it is the point of the research or the statistics that we wanted to see how much this is reflective or representative of the parameter or the population itself. So again, statistic is on the level of the sample, parameter is on the level of the population. So to give you the entire picture here of these concepts, population is the entire element or all the components that we wanted to study. And from the population, we only select the sample. The process of extracting the sample is what we call the sampling procedure or technique. And out of the sample, we try to measure the sample in terms of different attributes or characteristics. And this is what we call statistic. And the processes that involves in extracting the statistic is what we call the descriptive statistics. This is where we talk about central tendencies, dispersion, distribution. Okay, that is descriptive statistics. We try to describe from the root word. We try to describe the realities of the sample size. And out of the statistic, we try to again arrive at how this is also reflective of the entire population through the parameter, the measurement of the population. So from this, we might extract conclusion, and the process of which is what we call the inferencing or the testing of hypothesis. And arriving and confirming this parameter to the population is what we call the inferential statistics part. So from the statistic to arriving at drawing at conclusions that is true to the population is the entire process of inferential statistics or gathering inference. So to infer means to conclude, to arrive at a conclusion. Okay. So this is the picture of the relationships or what we call the concepts of population, sample, statistic, and parameter. And this is also the big picture on how we will be dealing with our statistics later on. See, see the beauty of this that when we try to apply it, we want to know something about the population. So, however, we cannot really reach the entire population and interview all the elements, interview all the citizens or the participants. But what we do is try to maybe select a few or a portion of that population. And out of that, we can work with that and maybe interview them, survey them, and extract from them information. And the information that we will gather, we try to measure it. That is where the statistics come in. For example, the mean scores of the responses of the respondents or the participants. And from that, we try to, again, generate a bigger conclusion. We try to correlate it, we try to compare it. Then we arrive at a new information coming from the statistic that is the part of the parameter, reflective of the parameter. And the parameter, again, is the characteristics or the measurement about the population. Okay. So to give you a juxtaposed distinction between population sample, by definition, this is the collection when we pertain to the population, and sample is only a part of the population. In terms of characteristic, this is manifested by the terms parameter with regards to population, and with the sample, this is reflected by the term statistics. And in terms of examples or symbols that are parametric, for example, will be the total population, the population mean, or the small letter Greek alphabet mu, the small letter sigma for population standard deviation, and the pi for population percentage. For the statistics, the small letter n will reflect the or represent the sample size. The x or the x bar will be the sample mean. The s, small letter s, will be the sample standard deviation, and the small letter p will be the sample percentage. Okay, so we deal with variable. This is another concept that we need to understand. Whenever we try to study an attribute, a trait, a characteristic, for example, an age, gender, weight, your educational attainment, your socioeconomic status, all of this is what we call variable. This is a property or element of a certain population or uh, individual or sample or any participant or respondent or any uh, source of information. So the variable is very broad and very encompassing, but there are classifications of variable. So what we need to understand is that first you can classify it according to quali and quantitative categories. For example, qualitative variables are categorical by nature, which means this involves not numerical data, but in terms of words, terms, labels, letters, traits. Example will be gender, male, female. That's a qualitative categorical variable. In terms of quantitative numerical variable, we have here measures of numerical quantity or amount. This could be in terms of age, or let's say temperature, or BMI, or scores, or any numerical assessment. So this could be subdivided in what we call discrete numerical or quantitative variable and continuous numerical variable. When you say discrete, we are pertaining to whole numbers here. For example, the number of students in school, it's a very discrete. There's no such thing as a three and a half number of students. Instead, we have three or four. So that's very discrete. While on the continuous side, we have here the infinite values of numbers in any point of line interval. So which means decimal values could be a portion of this, like an interest rate that has a continuous numerical value. So it is not counted as whole discrete numbers. So that's the distinction here. Okay. Now we can also try to classify variables according to the type of data, or in a more appropriate term, we call this the data scales or scales of measurement. So to allow you to understand the different scales of measurement, please bear in mind that there are four types of scales of measurement. You can use the acronym IRON, IRON. I stands for interval, R stands for ratio, O stands for ordinal, and N stands for nominal. So it's easy to remember IRON. We start with the numerical parts or the numerical scales of measurement. This is interval and ratio, the last two portions there. Interval can be these are numerical data that can be manipulated, and however, they don't have an absolute zero. That's the only difference here between interval and the second term ratio. Ratio are also interval scale or numerical data, but they have meaningful zero. What do you mean by meaningful zero here, or let's say absolute zero? That zero has a value here. It has a place. Unlike the interval, that it is only part of the numerical figure, but doesn't really occupy content. Now, it might be confusing for some, but simply to wrap this two is simply to tell you that interval and ratio are both numerical data, as simply put in that part. On the other hand, when we talk about ordinal, look at that word ordinal. It came from the word order, which means there's a certain scale or gradation or level. So when you say ordinal data, look at that word, there's always a certain hierarchy or a certain rank, level, or gradation that we are pertaining to. So what are the examples of ordinal data? Uh, the common Likert scale, the common rating scales like strongly agree, agree, neutral, disagree, strongly disagree, or always to never, or simply the ranking, first, second, third, fourth, fifth, last, first. All of these are part of ordinal data, or as long as there's gradation to that. The example given here is 1, excellent, good, 2, fair, 3, and poor will be 4. So there's this interval of or gradations or levels or a scale. That's why we call it ordinal. It might be represented by numbers, but mostly this is described by words. But again, the concept here is not purely words or labels, but instead there's levels or scales or ranks. The last part here, or the last term here, will be nominal. When we say nominal, this pertains to, from the word itself, nomen, names. These are usually categorical terms, words, labels, descriptions, letters, or simply terms that try to distinguish things or put labels on things. For example, here, Democratic, Republican, Independent, they are not in terms of levels or hierarchy, so they don't fall under ordinal, but instead they fall under nominal. And also, the distinction between male and female are very nominal. Again, the keyword here is the root word nomen, or as the etymology implies, nomen means name. So the name here of the terms used are the ones that we are using as part of the scales of measurement. Okay, so again, the numbers, the numerical data that you encounter when you try to ask for surveys or uh, interview people, when you get their data, when you have, let's say, scores or grades, these are part of interval and ratio. But when you have, let's say, you ask them to rate highest to lowest or first to last, then you're asking ordinal data from them. And when you're only maybe using them labels or, let's say, distinguishing them from gender or simply the terms or categoricals, then you're using nominal data. You see the distinction? These data are very important later on how you try to analyze and choose the right statistic or the right statistical test to analyze the data. Again, this is vital later on in your testing and in analysis of data. So learn to distinguish the scales of measurement or simply the type of data. Now, another distinction in variables will be the common classification in terms of functional relations or functional relationship. You might encounter that in researches, you usually try to distinguish which is the independent from the dependent, or even from the title itself, you already demarcate which variables are independent variables and which are dependent variables. This is that part, the functional relation. Why functional? Because there's the reason why you call it independent, because it is the one that stands out independent from the variable, but instead it is also the one that influences and affects the other variables. That's why you call it independent variable. On the other hand, the one that receives the influence, or the one that try to receive the effect or reflect or represents or manifests the outcomes is the dependent variable. From the word itself, dependent, it depends on other variables for the variation or the changes that or the effect that it incurs. So the distinction between independent and dependent variable are very common in statistics and even in research. This is also spelled out mostly. So independent variable, for example, are usually fixed variables that doesn't change through time, but I'm not saying absolutely. Example of which will be age, intelligence quotient, or even gender. Um, Independent variable are usually constant, and it is the one that affects the other variables. Dependent variables, on the other hand, for example, will be uh, level of awareness, the scores in a test, or let's say the reception or the degree of participation. So these are usually at times relative or dependent on another variable, whether it increases or decreases. So that's why you call it dependent variable. Now there's also a third type of variable here, the covariable, or sometimes they call it the mitigating, the intervening. There are other types of variables here, and the confounder rather variable. It affects the dependent variable in certain sense, or even at times, even the independent variable, but it is not your primary interest in the study. Okay, so set for example, the question on your research is about the relationship of study hours to the learning outcomes of students. If you try to look into the study hours of a student and try to see whether these students have longer study hours and certain students have shorter study hours, whether this influences their learning outcomes or their understanding or their performances in school, then you will try to jump into maybe some of the assumption that the higher or the longer the study hours, the higher the learning outcomes. And inversely speaking, the lesser the learning hours, or the study hours, the lower the grades. Unfortunately, sometimes there could be a confounding portion where whether certain students have also shorter number of hours and other students have longer number of hours, study hours, but try to exude or try to um, develop the same grade level or the same learning outcomes. This is when the confounder or the, let's say, the covariable comes in. It might enlighten the researcher that there are other factors or elements that might influence the dependent variable. For example, uh, the one that has lower learning hours or study hours has higher IQ or intelligence quotient, and the student with longer study hours, let's say, have an average intelligence quotient, and therefore they might have the same learning outcomes. So these are just some of the examples that might come into play in the relationship of the variables when you try to understand the influence of one to the other or the effect of one to the other. Okay. So finally, when we try to look at all of this, we try to label them according to descriptive statistics and inferential statistics. As definition, again, by in our earlier discussion, statistics starts from the gathering of data, analyzing data, presenting data according to how it tries to present itself to us, like the phenomenon. We try to organize the data and describe the data. For example, the number of participants involved, the percentage of participants in certain attributes or traits or elements. These are all part of descriptive data. Now, when we deal with the analysis of this data, then later on we try to come up with a different idea, conclusion arising from this data, then we are already embarking to inferential statistics. And inferential statistics are information contained from the sample, then we try to arrive at the population description or population characteristics or traits. So we try to draw conclusion from it. That's the inference part. So descriptive from the word itself, it describes reality, it describes phenomenon or the data that we are analyzing or studying. Inferential comes from the word infer, which means we try to draw conclusion, we try to arrive at a judgment or a decision. We try to formulate something new, a novelty out of the given data. So to infer means to arrive at a conclusion. To infer means to generate something new, discover something new. So I hope you were able to understand the different key concepts and definitions that come into play when we discuss inferential statistics or statistics in general. These keywords are vital in the understanding of the overall course, and I hope you learn from it and see you on our next lecture. Have a great day, everyone. Namaste.